Accepted.
Okay. Hello, everybody. Thank you for that you've decided to pick today's session. It's entitled, I have to really try to memorize the title, Is Your JVM App Flying Blind? Unmask Hidden Issues with Observability Superpowers. Absolutely, it has not been generated by ChatGPT, because if it was, you would have the word Delph in it, and there is none, so no ChatGPT this time. My name is Marcin Grzejszczak, and I'm a developer at the Spring team and the Micrometer team at Broadcom. If you want to get in touch, you can find me on Mastodon. There's my Twitter handle and my blog. I'm not blogging too much, so if you're interested in any of my previous talks or courses, you can check it out over there. Hopefully, because today's session is going to be, like, I have no slides. I have just the ASCII doctor generated docs for today's session, and I have a lot of demos and a lot of live coding. The last time I have done this session, it was a complete disaster. Everything blew up, like completely everything blew up. So this time, because I tried not to replicate mistakes, I have a screencast. If anything goes wrong, I have a screencast that we will go through. But right now, I can see some stuff working, so maybe it's not going to be that bad. Okay, so before we go to the main topic, I have a poor man's version of a poll. So who of you is using observability in production, whatever that means to you? Observability in production. Okay, a lot of people, great. Who is using Spring Boot 3? Nice. Who is using Micrometer? Okay, still a lot of people. Who's using Prometheus? Oh, even more, great. Who's using OpenTelemetry? Okay, a couple of people. Okay, so now I more or less know what you know about observability. Now, what is observability? Let's define it in such a way. So how well we can understand the internals of a system based on its outputs. And this is a very important thing, based on its outputs, because if the demo gods are with me today, I will show you one way of outputting information about the internals that is related to music. But we'll see about that. A lot of stuff has to be working, and rarely during the presentation everything works fine. So let's talk about the system architecture. It's a fantastic graph. It's the best I can do. So by the way, I've been doing tools for the past decade or so. So it's fantastic that I can now convert into a developer that is delivering business value. Finally, of course, those who do know me would start laughing right now because I haven't touched business code for a decade, but it's high time I do this. So what I will show you today is a tea house application that will tell us how to brew or steep tea. So on the edge, we have a T service that over RabbitMQ will connect to a reporting service that will store information in MongoDB. So we have messaging and MongoDB. T service will also communicate via a proxy service, which is a gateway, a reactive gateway. We'll communicate with a T-leaf service that communicates with a Postgres database. And the T service also communicates with the water service that goes to the database. So that's the introduction. So now, time for the actual demo to see the application. So our best developers were working on the UI. It's using the 21st century full stack of the most hyped libraries. And like without any further ado, let's look at that. There you go. So that's the UI. It's reactive because it reacts to my clicks like this. And it's responsive because when I click, it responds with the table. If it was last year, I would say it's Kubernetes, because why not? Everything is Kubernetes. So this year, I can say it's AI-driven. There's AI somewhere over there. So as you can see, everything works fine because like we deliver as a company. You can pick a tea leaf, and then things are just working great. Okay, let me refresh this. Okay, so apparently there is a problem. I wonder what that means. Internal server error. Most likely there's a server, and internally something is wrong, right? So internal server error. Let's try to debug this somehow. And to do that, we're going to use a monitoring system of some sort. Today I'm going to be using the Grafana stack, but it doesn't matter what you have. Whatever you have is fine. So what we have here is a dedicated dashboard for the T API. We see the latency. The green heart means that everything is fine. Here we can see that we have a problem with throughput. We have some successes, and we have some server errors. Who thinks we should have 0 server errors? Okay. Who of you has 0 server errors in production? We all know those, like, you know, there is this error. It's been here for a decade. We don't want to touch it because once we fixed it, we had 2 other errors, so it's better to have 1. So yeah, I mean, in our case, we want to have 0 because we have a very good quality of code, and we want to reach 0. So something is wrong. Here we have all the steep T's, and below we have a histogram with buckets of requests. So latency is around 11 to 30 milliseconds. So what is going on? Oh, and by the way, since we are, I am on call, my email server has received some problems, some information like high error rate tea house. Wow. And the rest doesn't matter. Let's completely remove it. Like, who cares? It's been resolved. So the problem ignored long enough resolves itself. So high latency has been resolved. So we can safely remove it. So let's now think about this problem with throughput. So we have some problems with English breakfast. So what we can do is we can jump to the logs. And this time, when I was doing this presentation the last time, I had no logs, so hopefully I'm going to see them. And let's search for logs related to English breakfast. English breakfast. And let's pick an app. Let's say the tea service, for example. And let's see if we have anything. Oh, we do. Whew, that's fine. At least something works. And let's pick a level error. Do we have anything? Oh, okay, let's pick a different service. Tea leaf service. Ah, there you go. Okay, so it seems that it's not a single problem. Like, it's not the fact that I have a problem with my machine, but right now, by the way, there are around 4 requests per second coming to our fantastic tea house application. So there's a lot of users clicking around. So it's not just me having this problem, it's a global problem with the English breakfast. Okay, so now we are in the space of logs. Oh, and by the way, all the applications that I've shown you, so the tea service, tea leaf service, etc., these are Spring Boot free-based applications that are using micrometer observation as the API that is used to instrument the code. As the distributed tracing framework, we're using OpenZipkin Brave, and for metrics, we're using Prometheus. So this is like the how it looks like from the backend side. So let's pick one of those logs. I mean, we see something, resource not found, or fair enough, whatever. An important thing is that since our applications are using distributed tracing, what we have in the logs is the trace identifier. I think that if you have been to a presentation related to distributed tracing, I don't have to explain that. So maybe I'll quickly ask you, who knows what a trace identifier is? Okay, I think everybody. So in general, it's a correlation ID that is the same for the same transaction. So right now, what we can do is we can jump from this infamous pillar of observability from one to another. Because having them separately is not ideal. The thing about, let's say, analyzing events such as logs, traces, metrics, is to have them correlated. So here we jump from logs to traces by means of a trace identifier. So now you can see that we have the waterfall graph of of the transaction. And here we have the red circle, exclamation mark, showing that there is a problem. Indeed, there was an exception. So we have all of that due to the fact, or thanks to that Spring Framework 6 is natively instrumented using micrometer observation. So I have tweeted about this today because I've been to a couple of talks related to OpenTelemetry, and I have heard the term like use the agent with Spring Boot. So I want to like globally state this. Do not use the OpenTelemetry agent with Spring Boot because Spring Boot itself is natively instrumented using micrometer observation. So if you want to use let's say a Spring Boot with OpenTelemetry, you can bridge via micrometer tracing, or you can create your own handler to directly go to OpenTelemetry. Do not use the agent because the agent is buggy, and then we get issues that, for example, a private method was used to instrument Spring, and we have changed the order of arguments, and suddenly something blew up in the agent. So, and also with the agent, you cannot create a native image. And with native Spring Boot micrometer observation instrumentation, you can. Okay, let's come back to this. So we see that stuff is happening, but we have a problem with the tleaf service. There's an exclamation mark over here. What is going on? So we see that the tleaf service is trying to find something by name. We go to the query. We have span attributes, so we have the select statement. Because we're using JDBC observations project, we have instrumented the data source, and we have configured it to have the query parameters. So we do a select, and we get JDBC row count equal to 0. Ah, okay, so we asked for the English breakfast, but we never had it in the database. Okay, it happens that the front-end people were too eager to fill up the combo box, or maybe we should have filled out the combo box based on what we have in the database, right? This is more intelligent. I wrote this, so it's not that intelligent. I have fixed the value and forgotten to enter the English breakfast to the database. Okay, so let's try to fix this. By complete chance, I don't know how this happened, I happen to have the add English breakfast HTTP call ready, right? So let's try to run this to see if I will be able to. Okay, so we got 201, so order has been successfully added. So now, what should happen is, since we've managed to, let's say, dissect this problem and analyze the issue using distributed tracing, and most likely we found the culprit, which is the missing English breakfast, we should start seeing the throughput in terms of success go up, because that's the only problem we should have so far. In the meantime, if we have managed to fix this issue, we should get the green heart of it here, because we would be having 5 successful requests per second. So the only thing we've managed to do to achieve this was to send this fantastic request to get English breakfast back. Okay, yes, so I could theoretically finish today's presentation because we did what? We fixed the problem. So due to the fact that we started from metrics, we've analyzed that there is a problem, we went to the logs, we found one of the logs related to a problem, and then we went to tracing and dissected the issue, and we fixed it, and now we can go home. High error rate. That's unfortunate. Maybe, for sure, my email server is broken. Let me check the dashboard. Okay, so that's what always happens. When you fix one problem, you get another one, right? So we did manage to fix it because we did go through like to the green part. And now, for some reason, after I have added the English breakfast, we have achieved a situation that our throughput goes drastically down. So maybe I shouldn't have added the English breakfast because at least majority of requests was good, right? So maybe I should remove it from the database and we're going to go back to the proper result. I highly doubt it. Okay. So we have another problem. Let's try to figure this out. It seems that we are around 3 requests per second of server error and 2 requests per second of successes. What we can do is use something which is called exemplars. So I don't want to go to the details of the actual algorithm behind this, but let us imagine that whenever we are capturing metrics, every now and then, if there was an active span, this span will be attached to the metrics. So this is a correlation of metrics and tracing. So now if you see those little dots over here, that represents an exemplar. So this is a trace that was correlated with that particular metric. So what we can do is take one from the history when everything was fine. I have too big of a font. Okay, query with tempo. So here we have a successful scenario. And now let's pick one. Maybe you're going to be lucky. That is, come on, that is faulty. Okay, so now let's compare the two. Where is the trace ID? There you go. Okay, so let's pick this and this. Let's split this. And let's compare them. So to the left, you have the proper one. And to the right, you have the invalid one. So to the left, we're going from the T service to the reporting service, and there's a proxy, etc. And here, we're going from the T service to the reporting service and to the proxy, and we finish here. What is going on? Let's look at the faulty one in more details. Okay, so there's a proxy service. What is this quota span? Like span attributes, max request, quota allowed false. I have no idea what that is. So there is a reporting service, and there are some span attributes that I don't understand. There is also, oh, I remember that. There is also a dedicated dashboard for the reporting service. There it is. Okay, what is, no, not the reporting service, the proxy service, I'm sorry. Okay, so what is this? Quota request throughput, that's a lot. So if only there was a way, there was some documentation of those metrics. Who loves writing docs? Okay, two people. Okay, that's a lot, that's a lot. I expected one. So this is twice as many as I expected. So nobody likes writing docs. Who likes when their docs are written for them? Ah, perfect. So how about we had such a situation where you describe your observability data, like this is an observation I have, these are the high and low cardinality tags that I have. What are those? So if there's a low cardinality tag, that means that the value doesn't differ a lot. High cardinality means it does differ a lot, right? So typically low cardinality data goes to the metric system, and low and high go to the tracing system. If you have high cardinality and you push it to the metric system, your metric system can blow up. So what if there was a solution that you define your observability data in a certain way, and then your sources get scanned, and documentation gets created by itself? What if there was such a solution? By chance there is. So if you're using micrometer observation, and you create, let's say, the description of your observability data in a proper way, I don't want to go into the details, it's more or less, creating an enum that implements an interface, never mind, it's in the docs. You can get documentation written for you, which you can attach together with your app. So here I went to the reporting service, to the actuator observability index.html page, because Micrometer docs generator project can generate ASCII doctor documentation for you. Then you can attach it to your app. And then we can go to the spans and see quota observation span. Okay, observation related to request quota calculation. In case of going over the maximum allowed request rate per second, rate limiting will be applied. Oh, so we have a quota for requests. So that means that we have reached the maximum amount of requests. Now in the cloud, now rate limiting got applied. So what we have to do is either wait, for example, 24 hours until the quota gets refreshed, or ask our managers to swipe the card and refresh the quota. So that's exactly what we will be doing, because believe it or not, I have a dedicated endpoint for that. So let us assume that the card was swiped, and now we should stop seeing the issue related to throughput and to rate limiting, which is fantastic. So I have to do one more thing here. Don't look at that. So, what happened now is we are getting to a proper place because we have a server error going down and success is going up. So, let's recap this part. What we managed to do is using exemplars, we've managed to check 2 traces, one before an issue and one after the issue happened. We've managed to analyze this situation, and we looked at the documentation related to observability data of one of the applications, and that way we were able to see that even the proxy service, the quota requests and throughputs are going up, which is great, so rate limiting got properly fixed. Now, we've managed to resolve this problem, but for some reason, we have yet another problem. So we are constantly fixing issues, and we're getting new ones. Now we have a latency problem, because until now, we had a very simple case. There was an exception, and there was another exception related to rate limiting. But now we have latency. So if you look over here, we can clearly see that something is wrong. Maybe Grafana is going nuts. Let's scroll down. No, it's not, because we can see that in the histograms that the buckets moved up. So we have requests in different latency range. So indeed, something is wrong. So let's try to do it again. Let's pick 2 traces, one from the history using exemplars, and one that is happening right now. So let's split this again, and let's see what we have here. To the left, we can see that the T-service took around 100 milliseconds, which is a slow one. And to the right, we can see that it took 163 milliseconds. Okay. If we look over here, we can see that we have an increased time in terms of going to the database over here, as far as I remember. So we have around 100 milliseconds over here and 154 milliseconds over here. So something is fishy over here. So most likely, the culprit is the database. So with Spring Boot, we give you quite a few metrics out of the box, one of which is a metric related to data sources. So we're going to go there in a second. But so far, we've managed to jump between pillars in such a way that we started with logs. Via trace ID, we've managed to go to the trace view, so distributed tracing. So from logs to distributed tracing via trace ID. From metrics to tracing via exemplars. But can we go from traces to metrics? And the answer is yes, we can. So because we are using micrometer observation to instrument our code, we instrument once and have multiple benefits out of it. But what does it mean? It means that when we instrument once, we apply the same set of tags to both metrics and traces, or a subset of them at least, right? Because the low cardinality go to metrics, but low and high go to traces, to spans. So if we create a query for metrics that is parameterized, we can say, hey, give me the throughput, and here's the parameterized query that it gets filled with data coming from the span. So this is a view on the metrics. In this case, this is the throughput. We can pick latency, for example. So this is the maximum latency for the given application with the given tags that come from the span. So this is the closest we can get, what we can do to jump from spans to metrics. So here we have the rate of the latency, and we can see that it spiked over time. It wasn't that funny. Okay, so now let's look at the, so the culprit might be the database. So what we can do is we can go to our dashboard related to database. So if we go to the water service and we scroll down, we can indeed see that over time the connection time grew up. And why did it happen? Why did it happen? There's a number of possible reasons why it happened. One, somebody stepped on the cable, right, that passes the bytes to the database. Maybe somebody has started doing some terrible things on the network, and let's say we've managed to use all the bandwidth. Or maybe somebody has introduced toxic proxy, a proxy service that has introduced fake latency of 100 milliseconds. And right now I have removed that fake latency, so we should see in a minute that the latency goes down. So this is, I'm a bad person. So I've managed to hijack the TCP connection and introduce fake latency. And anytime, hopefully, we're going to see that the T-service latency falls down. And yeah, there you go, it goes down. So the last thing I want to show you in this part is something related to Mongo. I am not a Mongo expert, but I know one. So I asked ChatGPT. I said, hey, Chat, the thing is, and I've given like a long context about like, you know, I'm going to Devoxx, I'm doing a presentation, I know nothing about Mongo, I want to showcase observation of Mongo. Can you help me out and tell me what can I showcase? And Chat actually told me what to do. Chat told me, hey, how about you show indexes? I'm like, wow. And it has given even me the snippet. Of course, it didn't work, but I managed to fix it, and it did work. So let's check it out. So let's look at the reporting service. Reporting service is over here. There you go. So if we look at this fabulous Vaadin table, we can filter by tleaf. I can type in Sencha, and we have the result. So the result is extremely fast, because I think I've forgotten to populate the database. We have 1 million records, which I might do, or it's actually too late. Let me see. So if we go to Mongo, how many objects we have? 11,000. That's highly unfortunate, but we'll figure it out. So I have a special process over here, which is called batch insert data. I will try to fix some stuff very fast. Server port. Let's do it like something like this. So if I run this, hopefully, and if not, then I will show you maybe the screencast. What should happen now is I should connect to my local Mongo installation and upload 1 million records, because like I said, I am not an expert. Will it work? Come on, come on, come on. It's inserting, okay. So I'm absolutely not an expert with Mongo, and I initially did similar things, so I have inserted like 20,000 records, and I'm talking to a friend of mine saying, you know what, like when I look at the statistics of the find, it takes one microsecond or 2 microseconds. It doesn't sound a lot, right? So if I apply an index, it changed from 2 microseconds to 1 microsecond. It's not really fantastic to show that, right? So he said, like, you know what, maybe try inserting 1 million records. And I'm like, oh, that's a good number. So right now I've added, hopefully, 1 million. Oh, there you go, this is much better. So now if I try to search for Sencha, that should take, now it's longer, great. So if we go to the dashboards and go to the reporting service, now, great, now we can see that we used to have like really no time at all to retrieve this because we had not a lot of data. Now we have 1 million records and the query duration goes up, right? So due to the fact that Spring Data MongoDB also uses micromirror observation, because like I said, all the Spring frameworks, Spring-related projects are using micromirror observation for instrumentation, we can see these metrics and we can see also spans in tempo related to Mongo. So right now what we can do, because you can obviously see that it takes around 0.4 of a second to run the query. I have a fabulous UI because I have no idea how to do it from the command line. I will add a index for the tleaf And if I create the index, what we should see is that the query will drop dramatically. And only because we have added, let's say, Spring Boot actuator on the class path that takes in micrometer. And we have added micrometer registry Prometheus that configures Spring Boot with Prometheus. We are able to see this, and we are able to react accordingly by, for example, asking ChatGPT how to improve this. Okay, so now we can see that we're falling down from 0.4 of a second, and we will be able to fall down to like microseconds or like milliseconds in very soon. Yeah. So we are dropping to like a ridiculous amount only because we have index, which, like, by the way, is not always the solution. This is just a demo, because if you do a lot of writes, that would be much slower, right? Okay, so to recap, I'm going to show you just one last thing, is the logs, traces, and metrics. If we pick one of those. To recap this whole part, what I've managed to show you is that we've managed to go through from messaging to databases of different types, reactive, non-reactive applications. Everything got automatically instrumented natively. Because what we believe in is that if we want something to get instrumented, we should go to that project and instrument it natively. Thanks to that, you were able to see metrics and traces. Plus, we've managed to jump between different pillars, so logs and traces via the trace ID, metrics and traces via the exemplars, and traces to metrics via the same set of tags on a pre-configured query. And now what you can see here is all those three pillars on a single graph. So you have the logs for a given trace ID, the trace view, and, for example, the metrics from the similar time. Now, because yeah, I want to show you one more thing. We talked about the outputs. One way of outputting things is to present the requests in a different way, right? Because you can see metrics, and here you can see tiles with the number showing the milliseconds which were required to process the given request. But that is not all. You could do something more interesting. Who of you knows how to read notes? Music notes? Okay. Who will tell me what this, if you know what this melody is, please raise your hand. Does anybody know? No? Okay, I will try to turn on the music. I don't know if it's going to work. Okay, 1, 2, 3. Is what? No. What is this? Yes, never gonna give you up. So what's actually happening right now, the requests are coming in and they're playing Never Gonna Give You Up. I'm not saying you should be doing this in your production code, but this is one way of doing things. So actually my colleague Jonathan Ivanov has written that, but he also has done something else, that when a request is read, so it's errorless, a crash happens, like a symbol, and there are drum sets playing when you are having like a successful request. Just consider that, right? Okay, so now, by some miracle, everything worked. So now let's do something even more crazy, which is I will instrument with you an app from scratch. So what I want to show you is how to use micrometer observation in order to instrument Javelin. Who uses Javelin? Okay, almost nobody. That's fine. It's a server, whatever. And the Java HTTP client. We're going to be doing that. So now, I'm using Maven archetype. Who has ever used Maven archetype generate? Okay, cool. Old people are here. Good. So now, I'm using the same thing, interactive mode. So let's use com example over here. Artifact ID, Devoxx PL, version 1.0, whatever. There you go. Let's open the project. Java 1.7, yeah, that's cool. 21. JUnit 3, fine, nice, hardcore. Okay, build, plugin management, goodbye. Okay. So, we have now even some site over here, great. So this is the app. Now, what we will be doing is I'm literally going to the docs of Javelin, and let's try to copy some stuff from the docs. So this is how you add Javelin, fantastic. Okay, the dependencies. I actually know that we should add bundle to get bundled dependencies. Actually, I should have a small hint over here. Oh, there you go. I'm going to take also the SLF4j API. There you go. Okay, let's refresh it. And now let's copy what they show in the tutorial. Okay, public static void main, whatever. Let's copy that. Okay. So if we run this and I send a request to 7070, then what should happen is we should get a reply back with hello world, HTTP 7070, hello world. Okay, fine, it works. So now what Javelin allows you to do is to have a before and after handle. After. And over here, let's system out something. Before and after. And here, let's do some processing. Okay. Processing. Okay, let's rerun this. Goodbye. Okay. Hello world, and in the logs we see before processing after, right? This is as simple as that. Now, what we will add is we will add micrometer observation. So for that, we're going to add the micrometer BOM. BOM is the bill of materials, so that's a special POM that, when referenced, will contain all the versions of all the projects or artifacts related to this particular project. So in our case, I don't want to pass the version of micrometer observation jar. It will come from the BOM. Okay. So I have added that. So how do you do it now? You create an observation registry. Okay. And now what we will do is, before our request comes in, we're going to create an observation. Observation before. Observation start. We're going to give it a name before. And we're going to pass in the observation registry. Now, we need to, what we're going to do is we're going to do something like scoped, which means that if in the future we would like, for example, some MDC or something like that to get populated with some data, that's only within this scope. So this is how we do this. Now we need to pass things between methods, before, get, and after. So we pass it as an attribute. Let's do it like this, ops. And we pass the observation. Now we retrieve it over here. Context, CTX, attribute ops. So we retrieve it, observation. And there we go. So now we can create a child observation. Why not? So first of all, let's put this in scope again. And within this scope, we can create the child observation. As you can see, I have not mentioned any tracings, metrics, nothing. We're just observing. It's abstract. Observation, start, let's call it a child. And let's pass in the observation registry over here. And now the child observation will be scoped over here. In the meantime, we can stop doing hello world. We can use an HTTP client. New HTTP client that comes from the JDK. HTTP client. Here we're going to do an HTTP request builder. And we're going to send a request builder. That's going to be a get to a headers endpoint URI. I have in a Docker container HTTP bin running. I have to just check what was the port because I don't remember. Anybody knows HTTP bin? Okay, so for those who don't know, HTTP bin is the 1, 2, 3, 4, 5. That's a good port. It allows you to test your HTTP requests. It's running in the cloud, http-bin.org, but the problem is that once I tried to connect to it during the presentation, I got socket timeouts or something like this. So this time I'm running it locally. So let's do localhost 12345/headers. What's the problem? URI. Oh, there we go. Body handlers of string. Of course, checked exceptions. Okay, introduce HTTP response. There you go. HTTP response body. There you go. Okay. And now, so we did that. Now, in after, let's take the observation in the after section. Context, and let's close it. Stop at the end. And here we do observation scoped. There you go. And here I think I've forgotten to stop this one. Child observation start. And in the finally block of this one, let's close it. Okay. So what we managed to do is create an observation when the request comes in, create a child observation for the processing. We started them, stopped them, and put them in scope. That's it. We run this. We got back the headers of our request, which is great. And nothing else changed. Why? Because what we did right now, we have instrumented the code to some extent, but we have not provided any features, right? So how about what we do right now is we add metrics. So to do that, we will add the micrometer registry Prometheus. I think that's it. There you go. Let's refresh it. And now let me copy some fabulous code. Okay, so what we have right now is a Prometheus meter registry. So micrometer works in such a way that you have meter registries. Depending on what kind of meter registries you have, some stuff will happen. For example, you gather metrics in a Prometheus format. So this is why we have Prometheus meter registry. And also, I'm running the HTTP server on port 4567 that will publish under the metrics endpoint metrics in the Prometheus format. Right? This is what is required by my configuration of Prometheus. So here I have the Prometheus meter registry. And over here, I will add new configuration. So right now, I am adding the metrics feature to our setup. And I'm doing new default meter observation handler like this. So what is this handler? What if, for example, I would like to add logging? So what I can do is create a static class myTextHandler, implements observation handler of any type of what we call observation context. And we can say that on start, we want something to happen. On scope open, something to happen. On close, on stop, like whatever. And now I can system out handler start, handler scope opened, handler scope closed, handler stop. And I want this to happen for every single observation that we have. This is why we say support context. So if I want this feature to be added, I don't change any of the instrumentation code. What I do is I add, I update the configuration. And I do, that's it. So now what I expect is I'm going to have two things, logging and Prometheus metrics. Okay. So first of all, 7070. And now you can see handler stop, handler scope close, open, etc. So we have added a new dimension of features, so to say. And now do we have metrics? What was 4321, I think? Prometheus? No, metrics. Metrics. No, what was the port? I've already forgotten. 4567, of course. 4567. There you go. So right now you have the child coming from the child observation, right? And you have the before coming from the before observation, right? So we have not talked about any tracing, any metrics related stuff for this block of code, and only by adding the handler suddenly features appear, right? Now, because I have 2 minutes left, so I don't think I'm going to be able to, let's say, write this. I'm going to copy paste this. Oh, what is this doing here? What I will do is I will show you the tracing part. So for the tracing part to work, you can use micrometer tracing. To add that, you add the micrometer tracing bomb. There you go. And you add the following things. Let me copy this whole thing. So you add the micrometer tracing bridge Brave. So micrometer tracing is the API that, let's say, allows you to use different tracers by just changing the class path. So you can use either Brave or OpenTelemetry. In this case, I'm showing you Brave. And Zipkin reporter means that we're going to publish the information in a Zipkin format. So let me quickly do this. There you go. Let me refresh this. And now the setup for tracing is a little bit big, so I'm not going to fully explain this. Actually, maybe I will even, let's say, show you the already working case. There you go. And I will just define this. So we have to create something which is called a micrometer tracing tracer, and we are using one from Brave. And then we are defining a, set of handlers, but related to tracing. So the same thing we did for metrics, now we're doing for tracing. I will not go through, let's say, other parts related to, let's say, observation. There are slight changes over there. I can share with you the code later. Let's just run this. Well, thank you. And now let's run this 7070. And now you can see by just doing slight modifications that are not related to tracing, we have started having the B3 related headers. So this is context propagation happening just by the fact that we have properly configured micrometer tracing bridge. And if we go to over here, we should be seeing, if I go to dashboards, do I have it here, TAPI? Okay, let us do explore. Hopefully this was got already. You see, before active seconds count, so our app got properly scraped. And if I go to explore to tempo, to Loki, we should be seeing, this trace ID. If I put it here, where is trace ID? There you go. Come on. Okay, something crashed. Oh, there you go. I pasted it 4 times, I think. Oh, come on. The last thing, man. Let me do it. A search or jump. Can I do it? No, I can't do it like this. What a piece of code. Let's do it like this. No? Trace ID. Damn. Oh, I know how we're going to do it. So let's go quickly to dashboards. Logs, traces, metrics. Maybe I'll be able to do it like this. There you go. And we have HTTP server requests, HTTP client requests. Everything works as it should. Okay, so to sum it up, I've managed to show you, hopefully, I mean, the demo worked, which is surprising. We've managed to show you how to jump between different pillars of observability. I've managed to show you how Spring Boot apps or Spring-based app work with micrometer observation, with micrometer tracing and micrometer core through and Prometheus. We've jumped through different pillars, and then we've managed to do a very fast instrumentation of Javelin and HTTP client, in which we've managed to even do context propagation, and we've managed to see how we can separate the two things, the instrumentation from configuration, and the most important thing is that you should never give up, like Mr. Rick, who has been singing with us to the sound of observability. So that's it from my side. If you have any questions, I guess we're out of time, so I guess you have to approach over here. Thank you very much.